Example number 1, area under the curve. Find the area under the curve of y is equal to the square root of x plus 3 on the closed interval -3 to 2 using 5 subintervals in RRAM, the right-hand rectangular approximation method. And the first thing we need to do is to calculate the width of each interval, or another way of saying it is find delta x. So we take 2 minus -3 divided by 5 gives us an interval width of 1. Graph the function in the interval and create 5 equal width rectangles with the right corner on the function. So this gray region represents the graph of y equals the square root of x plus 3. We begin our rectangles on the far left side of the interval range, the -3. We go over 1 unit to -2, and the height of the rectangle is set up in such a way so that the right-hand corner of the rectangle is on the graph of the function. Our second rectangle begins at -2, goes over 1 unit to -1, and it too is set up in such a way so that the right-hand corner of the rectangle is on the graph of y equals the square root of x plus 3. This continues in the same manner for the other 3 rectangles. Each rectangle width is 1, and the height for the first rectangle is at x equals -2. So the sigma notation that is created would be the sigma of 1 times f of I minus 3 as I indexes from 1 to 5. Now remember, 1 to 5 are the number of rectangles. What we want to have for the height is f in -2. So how do we relate our x value to our I value? Well, we hopefully can see that the difference is 3. So when I is equal to 1, 1 minus 3 is equal to -2, which is what I want in here. When I is 1, I want to have f in -2. That continues on to the last one. When I is 5, 5 minus 3 is 2. So our last value is going to be f at 2, which is what I want. And that also works for all the values in between as well. So now we evaluate our summation as I increases from 1 to 5. So at first, when I is equal to 1, our value of f of x will be 1 minus 3, which is -2. And f of -2 is equal to, let me get my highlighter, is equal to 1. Next, I will increase to 2, and 2 minus 3 is equal to -1, and f of -1 is equal to square root of 2. When I is equal to 3, x is equal to 0, and you can see up here 0 plus 3 is 3, so we're looking at the square root of 3. F of 0 is a square root of 3. When I is equal to 4, x is equal to 1, because again we're subtracting 4 minus 3, and f of 1 is 2. And then finally, when I is equal to 5, x will be equal to 2, and f of 2 is equal to the square root of 5. Summing all of these together, we'll end up with an approximate area of 8.382. Now that we've calculated the approximate area under the curve, would our estimate be an over or underestimate of the actual area under the curve? And the answer is that this would be an overestimate, because all of the rectangles have portions that are outside the area under the curve, and there is more area calculated than actually needed. This is evident if we look at the graph. We have these portions here where we calculated the area of the rectangle, but the area exceeds that of the curve. And all the areas I'm highlighting on your screen are extra areas that are over the actual area of the curve, which is indicated by this gray portion.